Yes, Martin, can you hear me now? Arshia, can you hear me? Please say something, yes or no. Martin, Arshia.
Yes,
Yes,
ma'am, I
ma'am.
can hear.
Yes, ma'am.
All right, all right. So this exercise 12.3 is about combination of plane figures, right? So here different types of figures are combined together. As you can see, there's a triangle in this figure, there's a circle in this figure. You can see segments also in this figure, isn't it? Yes?
Yeah,
Yeah.
ma'am.
Yeah. So let's see how we can do it. Okay, find the area of the shaded region in figure if PQ is equal to 24. Now, what is PQ? That means the diameter is given, right? So this diameter is 24 centimeter. PR, this side is 7 centimeter, and O is the center of the circle, right? So you have to find the area of the shaded region. How can we find it? So area of shaded region in this will be area of the semicircle, right? If I consider,
Yeah, ma'am.
yeah, if I consider this much semicircle, right? And then I subtract the area of the triangle, isn't it?
So we can subtract the area of the triangle minus area of
Yes.
the circle.
So area of shaded region will be equal to area of semicircle, correct? Okay. And minus area of triangle PQR. Is that okay?
Yes, ma'am.
Yeah. Uh, so first of all, area of semicircle. So this is just half of the area of circle, correct? Yeah.
Yeah, ma'am.
So uh, so one by one we will find out. Let us find out area of semicircle. Okay. So one by one we are finding. So it will be half of area of circle, correct? Pi r square, right? Now,
Yeah,
so
ma'am.
this will be equal to half into pi, which you have to take 22 by 7. It's given in the question. So 22 by 7 and into how much is radius here? 24 by 2, correct? 24 by 2 into 24 by 2 centimeter. This is also centimeter. Is that correct?
Yeah, ma'am.
Yeah. Now you can simplify this a little bit. So if you subtract, so this is 2 into 1 and then 2 into 11, right? Then 2 into 1, 2 into 12, then 2 into 1, 2 into 12. So basically now you have 11 multiplied by 12 multiplied by 12 and then divided by 7, right? Correct? So can you, and this will be now centimeter square. Now can you just multiply quickly? So this is 11 into, now 12 square is 144, you can directly write. Now please multiply 11 into 144 and tell me.
It's 1584, ma'am.
1584. 1584 and divided by 7, right? Centimeter square. Okay. Okay. If you can leave it like this in fraction, okay? Then let us come
Okay.
to area of triangle. So now I want to find area of triangle PQR, right? So basically you have a triangle like this time, and this side is given, which is 24 centimeter, and this side is given, which is 7 centimeter. Correct? Yeah.
Yeah.
Yeah. So what is the formula for area of triangle?
One by
Half base into height, correct?
half base.
Half base into height, right? Half into base into height, right? But there's a problem here. As you can see, you might be thinking that this 7 centimeter is the base of this triangle, right? And then the side PQ will be the height, correct? But
Yeah.
But to do that, we have to be sure that this angle is 90 degree. Then only PQ is the height of the triangle. Correct? Now in this question, it's not given that it's a right angle. Can you see that?
Yeah.
Yes?
Yeah, ma'am.
Yeah. So you have seen this formula, half base into height, is applicable when you are sure that this angle is 90 degree. Right? Then only you can say that this is height. So there's a problem. What will we do now? Is there any other way to find the area of this triangle?
Sin theta by 2 cos.
Mm, but is there any theta which is given here, Martin?
No, no.
No. Then how will you use trigonometry? Right. So this side is 24 centimeter. Okay. So here,
Yes, Pythagoras theorem to sin.
yeah, but Pythagoras theorem is also applied on a right angle triangle, correct?
Yeah.
And we don't know that this angle is 90 degree or not. It might be 91 degree. How can you say it is 90 degree, right?
Oh, yeah.
Yeah. So here we are going to use a property, right? Which you have studied earlier, or you will study in circle chapter, that angle in a semicircle is always 90 degree, right? So please try to understand, like if you have any circle and this is a semicircle, correct? This is the
Yeah.
center. Now, all these angles, for example, there's a triangle like this, I mean, like this, right? So this angle is always 90 degree, correct? There can be a triangle,
Oh, okay.
there can be a triangle like this also. So again, this angle will be 90 degree, or there can be a triangle like this also. Then also this angle is going to be 90 degree, right? So there can be any triangle. So all the triangles in a semicircle are actually right angled triangle, correct? So this property we are going to use here. Okay. Uh, so you will write, okay, you can make it as a heading first of all. So you can say this is in the figure, this is what? Q, R, and P, correct? Okay. So here you will write that since QR is diameter, right? So that means it forms a semicircle, correct? Yeah. So it's a circle is like this. Now because QR is the diameter, as you can see, it is touching the two ends of the circle. So therefore it forms a semicircle. That means this half portion is actually a semicircle, correct? Okay. Now there's a property that you can say we know that angle in a semicircle is a right angle. Have you understood this thing? So that means now we know that this angle is 90 degree, right? Now we can use Pythagoras theorem. So this is a property which we have used, right? So let us find out the height of this triangle. So from Pythagoras theorem, or you can say, therefore, triangle PQR is a right triangle, correct? Now we are saying that it's a right triangle, so we can use Pythagoras theorem. So from Pythagoras theorem, now what does it say? That hypotenuse is square. That means QR whole square is equal to base square, right? That means QP square plus height square. That means PR square. Is that correct? Yeah.
Yes, ma'am.
Okay, so QR is given, which is 24 centimeter whole square. QP is given, which is 7 centimeter whole square, and plus PR square you have to find. Right. So this is, can you just multiply 24 into 24 and tell me?
576.
576 centimeter square, okay, is equal to, this is 49 centimeter square and plus PR whole square, right? So 576 and then minus 49 centimeter
Yes.
square, yeah, is equal to PR whole square, right? Okay, so how much is this? 16 minus 9 will be 7. Then you have 6 minus 4 will be 2. Is that correct? Just 1 minute. What is the figure? PQ. Oh, okay. Wait. Sorry. I have marked wrong in the figure. That is why I'm getting something like this. Yeah, please correct your figure here. Yes, here. Sorry, there's a mistake. This is PQ, which is 24 centimeter, right? Can you see that in the question?
Yes, ma'am.
Oh, so there's a problem here. Just a minute. So this was actually PQ, which was 24. That means we have to do the question again. I'm sorry. And PR is 7, which is PR, right? This side is 7 centimeter. And O is the center of the circle. Okay, that's right. So that means the radius of the circle we don't know. Is that okay?
Yeah, ma'am.
Yeah, ma'am.
So that means first of all we have to find the radius of this circle, correct? And then we will be
Yes,
able to find the area of the semicircle. Okay, so there is a problem only here. Yeah, so this area of semicircle we cannot find right now. So you can just cut it in the copy, right? So this part we have to do afterwards. Okay, that's it. Now after this, so this part is right. So first of all, we are showing that it is a right angle triangle. Now the only correction is this, that this side is not 24, it is this side, which is 24 centimeter, right? Okay. So that means QR you have to find. So a little calculations here. This much is fine. Now just put the correct values. So QR we have to find, right? Now QP. So there's a triangle. I'm just writing again. This is P and this is Q, this is R, right? So PQ, sorry, this is Q and this is R. Yeah, okay. So this side is 24 centimeter and this is 7 centimeter, right? This is R, right? And this one is Q. Okay, so QP is 24 centimeter whole square. Now PR is 7 centimeter whole square, right? So QR square will be, you have multiplied 576 centimeter square. This is 49 centimeter square, right? So QR square is, now this is 6 plus 9 is 15, carry 1, then 7 and 8 and 4 is 12, and then 625 centimeters square. So QR is square root of 625 centimeters square, right? Now 625 is a perfect square of 25, we all know. So this is 25 and then centimeter, correct? So this side is
Yeah.
now 25 centimeter we have got. Is that understood by everyone? Yes?
Yeah.
Yeah, ma'am.
Okay. So we have got, right. So we have got the diameter of the circle. So let us find out the area of triangle PQR. First of all, so this is half into base into height, right? So put the values now. This is half into base is how much? 7, right? 7 centimeter, and height is 24 centimeter, correct? So this is yeah, so 2, that means it will cancel 12 times, and then 12 into 7 is 84, right? So 84 centimeters square is the area of the triangle, right?
Yeah, ma'am.
Okay, now you come to circle. So area of semicircle now. So this is half into pi r square, which is half of the area of the circle. Now you can write here. So radius is how much? 25 divided by 2 centimeter, correct? Okay, so half into 22 by 7 into, this is 25 by 2 centimeter into 25 by 2 centimeter, correct? Now just simplify this thing. I think you cannot cancel much here. Only this will become 11 by 7 into 25 by 2 into 25 by 2 centimeters square, right?
Yeah, ma'am.
So you can just multiply. So 25 into 25, we know this is 625. So 11 into 625, and then 7 into 4 is 28 centimeters square. Now, can you just multiply this quickly? 625 into 11.
Six eight seven five.
Okay, 6875. Good. Centimeter square and divided by 28. Right. So we have got the area of the triangle. We have got the area of the semicircle. So now let us find the area of the shaded region. You can write again, no problem. So area of semicircle minus area of triangle PQR, right? So this we have got 6875 divided by 28 centimeters square. And this was 84, right? 84 centimeters square. Okay. Now, obviously, you have to take LCM. There is no other choice. So here 28 will be the LCM, right? So this will be 6875 and then minus. So now you have to multiply 84 into 28, right? Correct? So
Yeah.
quickly multiply 84 into 28. Abdullah, can you tell me how much 84 into 28?
1352.
1352. Is everybody getting it? Martin, please check again. I think there's a mistake here. It should be a large number. See, it's 84 into 28, right?
Ma'am, it's 2352.
Okay. Right? Okay. Now let's centimeter square. Now just subtract it. So 5 minus 2 is 3, 7 minus 5 is 2, 8 minus 3 is 5, 6 minus 2 is 4, right? Am I right? And then divided by 28 centimeter square. So you can leave the answer here. The area of the shaded region is this much, 4523 by 28 centimeter square. Right, now next question. Find the area of the shaded region in the figure. Can you see the shaded region? Which is ABCD, right? If radii of two concentric circles, concentric means they both of them are having the same center, correct? That means O is the center of both the circles.
Yeah.
So they are concentric. The radii of two concentric circles with center O are 7 centimeter and 14 centimeter. So if I consider this a small triangle, which is BOD, sector, you can say BOD. So this is 7 centimeter and this complete is 14 centimeter, right? Respectively. Okay. And triangle AOC is 40 degree, as you can see. Area of the shaded region. So I think this is simple. You can find the area of the sector AOC and then minus area of the sector BOD, correct? So
Yeah.
area of,
Okay, so we subtract the area of the circle minus.
no, I think you don't have to find the area of the circle here. You can find simple area of sector, right? Use the sector formula, sector AOC, right? And minus area of sector BOD. Is that okay?
Yeah.
Yeah. So this complete sector, you are subtracting this much. So you will get the area of the
Okay.
shaded region, right?
So I'm minusing the big sector, small sector from the big sector.
Yeah. So basically this area you have to find the shaded one.
Both are 40 degree.
Both are 40° because they have the same center. So only the radii is going to change. That's it. So area of sector, you know the formula. You can directly put here, right? This is theta by 360 into pi r square. So one r you can denote by capital R, and then another r you can denote by small r. See, both are not the same radius, so you cannot use the same representation. Try to understand this thing, right? One radius is different from the other. So in the formula also you have to uh, put a different symbol for each. So you can use a capital R for one and then small r for the other. Is that clear? Yeah. Theta is same for both. So that means 40° divided by 360°, and into pi, if you wish, you can take common, into 22 by 7, right? And into what is the radius? That is 14, right? 14 centimeter into 14 centimeter. Sorry. And then minus again theta by 360. So 40 by 360 into 22 by 7. And other radius is 7. So 7 centimeter into 7 centimeter. Is that clear, everyone? I have simply put the values. That's it. Yes?
Yeah, ma'am.
Okay. So this 40 divided by 360 and then multiplied by 22 by 7. You can take common if you wish, right? So this is 14 into 14
You
minus
can take 1 by
7
9 for
into
40
7.
divided by 400. 40 divided by 360.
Yeah, so now you can simplify this, right, Martin? So this 1 0 will go and this will be 1 into 9, right? Okay, so you got now 22 by 7 into 9 is 63. And here, how much is 14 into 14?
This is 196.
196. Minus, this is 49, you know, and centimeter square, right? So this is 22 by 63. Please put equals to here, okay. And this will be into, now again 16 minus 9 is 7, right? Yeah, okay. And then 8 minus 4 is 4, so 147. So I think I can divide this by 7. So 7 into 9 and then 7 into 21, correct? Again 3 into 3 and 3 into 7. So now I got 22 multiplied by 7 and divided by 3, right? So 7 into 2 is 14, carry 1. So this is 144 divided by 3 centimeter square is the area of the shaded region. Done?
Yes, ma'am.
Okay.
Now can I scroll up?
Yes, okay. Okay, now next question. Yes, can you see the figure now? Yeah, so this is simple. Again, you have to find the area of the shaded region, right? Okay, now who will tell me how to find it? So ABCD is a square of side 14 centimeter. That means this side is given, which is 14 centimeter, correct?
Yeah.
Okay. And APD and BPC are semicircle. So they are saying that they are semicircles. So what will you do here? Can you tell me, Martin? To find the area of the
And
shaded
area of
part.
the
Hmm.
triangle size
Hmm.
square minus area of two semicircles.
Exactly, that's it, correct? So area of shaded region here will be equal to here area of square, correct? And then minus area of if you can name, so area of semicircle APD, and then minus area of semicircle BPC, right? So one by one, let us find all the three area and then we will put it. So area of square ABCD. So what is the formula? Mana? Yes, Arshia. How do you find the area of the square?
Side into side. Side into side.
Side into side. Okay. So this is side into side. Now side is given, which is 14 centimeter multiplied by 14 centimeter. 14 into 14 is 196, right? We have done in the previous question also. 196 centimeter square. Now area of semicircle. APD, right? So this is half of the area of the circle, right? Half into pi r square. So half into 22 by 7 into how much is the radius of this semicircle? Yes, Subhana, how much is the radius of this semicircle?
7.
7. Yes. Subhana, you're not speaking? Okay. So this is 7, right? 14 by 2 you can write if you wish. 14 by 2 into 14 by 2 because 14 is given in the question. So this is half of the diameter. Now you simplify. So this will become 11 by 7 and then into 7 centimeter square. Then 1 7 cancel out and 11 into 7 is 77. So 77 centimeter square, right? You can simplify on your own. Again, area of semicircle. Yeah, what is the name? BPC, which is again half into pi r square. Okay, then half into 22 by 7 into radius will be again 14 by 2 into 14 by 2 and then centimeter square, which you can again simplify. So this will become 11 by 7, and then here it will be 7 into 7 centimeter square, and it will be 77 centimeter square, right? Okay, so area of shaded region will be equal to area of square ABCD, right? Minus area of semicircle ABD minus area of semicircle BPC. Now put values. How much was the area of square here, which we just found? 14 into 14, so it was 196 centimeter square, right? Then this is 77 centimeter square. This is also 77 centimeter square. Okay. So both the minus terms can add, and it will be with a minus sign. So 196. And then how much is 77 plus 77? So 7, 7, 14, carry 1. So it will be 154 and centimeter square, right? And this is 6 minus 4 is 2. 9 minus 5 is 4. Yeah, that's it. 42 centimeter square is the area of the shaded region.
Yeah, ma'am. I have done.
Okay, so now can you see this figure? Now find the area of the shaded region. Can everybody see it? Okay, shaded means everything is shaded here, where the circular arc of radius 6 centimeter, okay, has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeter as center. So can you see this? There's an equilateral triangle, right? That means all the sides of this triangles are 12 centimeter. Is that correct? Okay. Now there's a circle, right, whose radius is 6 centimeter. It's given in the question. So uh, it is drawn like this. So one of the vertex is actually the center of this circle, right, with vertex O of an equilateral triangle AOAB. So that means you have a triangle, right? So this is the vertex O of this triangle. Now from this vertex, you have taken an arc of 6 centimeter and then you have just moved it like this. So it has become a circle on the top of it. Understood? And now you have to find the area of the shaded region. Okay, Arshia, can you hear me? Yes,
Yes,
Arshia.
ma'am.
Now tell me, what should I do in this question? First of all, which area I have to
Find
do?
the area of the shaded one.
Okay, how will I find it? Which figures I should consider here? Please tell me.
Both of them are shaded, but then
Hmm. Yeah.
OAB,
OAB is a triangle I can see. Okay. And
the circle.
circle. So should I add both the area you are saying?
Yes, ma'am.
Okay. Martin, what do you say?
Area of the triangle
Hmm.
plus area of the circle.
Circle. Okay. Mana, do you say something here? Subhana, can you say here something? Okay. See, there's a problem here. If I just do this thing that I am finding this area of the triangle, right? So that means this complete area I've already found, correct? Okay. Then this is the center and I'm finding the area of the circle. So area of the circle means, this complete area, right? That means this complete area. Understood?
Yeah,
So there's a problem here. This part, like using a different color. Now this green or red part, which you can see, this sector, right? This is actually being calculated two times. One time it is part of circle, one time it is part of triangle, right? So that means I'm finding this area in the triangle also. I'm finding this area in the circle also. Is that clear?
Yes, ma'am.
So I cannot add it. Otherwise, this area will be added twice here, right? So what I have to do is, first of all, I find the area of the triangle, correct? Okay. Then I find the area of this complete circle, that also correct. Then I will subtract.
Subtract.
Yeah, so this sector area I'll subtract. See, there's a problem. Um, this is a triangle. Now it's not a straight line, right? This is a circle which is going here. So that means it's not a triangle. It's actually a sector which is being formed. Understood? So after finding this, uh, okay, so after finding this circle, now try to understand. I'm finding the area of the circle, right? And I'm subtracting this sector, right? So only this white area I'm getting. Is that clear? Yes?
yeah,
Okay. Now what about this part? So this part is will be included in the triangle. When I'm finding the area of the triangle, so that means this part is included here, correct? So when I've already
Yeah.
so when I already subtracted the sector and then I'll add, so that will give me the area of the shaded part.
So we subtract the area of the triangle minus the area of the circle and add that with the circle.
No, 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 no. First of all, you find the area of the circle here, right? Wait, so you will find circle and then you will subtract a sector. Is that clear? Yes. So that
Yeah,
means
ma'am.
only this much area you will get, red one. This much area you will get, right? Now what is left? Only triangle is left. So then you will add this red area plus the area of the triangle. That's it.
Okay.
Yes. Okay. So triangle you will not disturb. The circle you will disturb. So out of the circle, you will subtract the sector. I hope it's understood now.
Yeah, okay.
Okay. So let us come to circle first of all. Radius is already given, right? So area of circle, which is pi r square, that you know. So this is 22 by 7 into radius is given 6 centimeter into 6 centimeter, correct? Now please multiply quickly.
6,792 divided by 7.
Okay, 792 divided by 7 centimeters square. Okay, then leave it here. Now you find the area of the sector. So area of sector ODE, right, in the figure. I mean, you can name it if you wish, like just make some dotted lines here, and this point you can call D, this point you can call E. So sector ODE we are finding out. So the formula, you know, theta divided by 360 into pi r square. Now what is the theta here? Can anybody tell me
It's
how?
60 because the
Exact.
equilateral triangle.
Very good. 60 degree divided by 360 degree into 22 by 7, and radius is 6 centimeter into 6 centimeter. So in the bracket you can write all angles of equilateral triangle are 60 degree. This you all know, right? Okay, so this you all know from your previous classes. Okay, now who will sum? See, 6 into 6 is 36, so the denominator will go, 0, 0 will also go. So you only have 6 into 22 divided by 7 centimeter square, right? Which you can multiply. 6 into 2 is 12, so 132 divided by 7 centimeter square, correct? Okay. Now I think you are done with it. Now you come to area of the triangle. Area of equilateral triangle. See, now this is an equilateral triangle. Now try to understand this thing. And what is given to you? Only it is given that the side is 12 centimeter, correct? Okay. So, can everybody hear me? Is everybody is here?
Yeah, ma'am.
Okay. See, now there's a long way of doing it. And if you already know the formula, you can directly use it, which is under root 3 by 4 into side square. This is the area of the equilateral triangle. See, it's not that tough. I tell you how you get it. So basically, you have an equilateral triangle. Now see here, this side is 12 centimeter. Now you don't know the height of this triangle, right? If you want to use the formula, half base into height, correct? No problem. So you will do a construction. So don't write it, just try to understand. Please wait and understand. So we drop a perpendicular. Now because it's an equilateral triangle, so it's going to divide this side into two equal parts, correct? So this will be 6
Yeah.
centimeter, this will be 6 centimeter. And then you will use the Pythagoras theorem here in this triangle. If I just call it ABC, so right, then you will find AB. So that will be the height of the triangle. So after doing all this, you will get the same formula which I'm using. Understood?
Oh, okay.
Yeah. You can check it like later on.
You can also
So
use the 1 by 2 into B into S.
yeah, half base into height if you want to use, then you have to use this whole process which I'm telling you. Pythagoras theorem and everything, and then you will put it in the formula. Right?
Yeah.
See, if you want, I can just show you quickly. You will get the same thing, Martin. Now, let us say this is an equilateral triangle of side A, correct? So I'm just dropping up median or perpendicular here. So this will become A by 2, correct? So I want to find the height, right? Height I want to find. So if I use Pythagoras theorem in triangle ABC, so basically AC square will be equal to AB square plus BC square. Is that correct? Please don't write it, just understand.
Okay, ma'am.
So AC is A square See, this is not the part of the question. I'm just discussing. So you please pay attention. So a square, right? AB I want to find. And BC is now a by 2 whole square, correct? So a square is equal to AB square plus, so this is a square divided by 4. So a square minus a square divided by 4 is your AB square, right? So you take LCM and then 4a square minus a square is equal to AB square, right? So 3a square divided by 4 is equal to your AB square, right? Then square root of 3a square divided by 4 is your AB, right? So
Yeah,
only under root 3 and then denominator will become 2 and this will become only a. So this is the height, correct? Okay. Now the formula is half base into height. Okay. So if I use half into base into height, so what will I get? So I get half into, now base is a by 2, right? And into height is this under root, sorry, no, sorry. Base is not a by 2, base is this complete, right? Which is a, right? Okay. Height I have found, which is root 3 by 2a. So what I get here, sorry, 2. So this is under root 3, 2 into 2 is 4 and a square, which is the formula I'm using here, right?
Yeah.
See, this is a standard formula. You can remember this thing. So you don't have to derive the formula in this question. In case you don't remember, then you can derive. Otherwise, you can just remember that the area of the equilateral triangle is root 3 by 4 into side square. So I have shown you how you are getting this formula. Correct, Martin?
yeah,
Okay, so I'm just skipping. If you want to write, you can write the derivation. Otherwise, yeah. So let us put the value here. Under root 3 by 4 into side square. How much is the side of this triangle? 12. 12 centimeter into 12 centimeter. So this is under root 3 by 4 into 12 into 12 is 144 centimeter square, right? And then you can divide this by 4 if you wish. So under root 3 into 4 into 3 is 12, then 24 will be 6 times centimeter square. So this is 36 root 3 centimeter square, right? Okay, so now you write that area of shaded region will be equal to area of circle, right? Minus area of sector OAB, correct? And then plus area of equilateral triangle OAB. Is that okay?
yeah,
Now we have already found all these things. Just put it here. Area of circle was 792 divided by 7, right? Area of the sector was how much? 132 by 7, I think.
yeah,
Okay. Area of the equilateral triangle is this 36 root 3 and everything is in centimeters square. Now you can just take the LCM and simplify. That's it. So LCM will be 7. So this is 792 minus 132 and then plus. So this will be multiplied by 7. 6 into 7 is 42, and then 4. So this is 21 plus 4 is 25, and 3, right? Okay, so 7, 9. So only this subtraction you can do, because this is a root 3 multiplied by root 3. You cannot disturb it. So 2 minus 2 is 0. 9 minus 3 is 6. 7 minus 1 is 6. So 660 plus 252 under root 3 and divided by 7, right? So this is yeah, that's it. This is the answer. Now you can put a bracket and write centimeters square. This is the area of the shaded region. Or you can do one thing also here, like after this step, right? After this step, you can just simplify the first two and then don't disturb the third term, because it's a different kind of term, right? So in the only the first two terms you can take LCM, and then plus 36 root 3 you can write as it is. Don't disturb it. So it will be simple 792 minus 132, right? So this will be 660 divided by 7 and plus 36 under root 3. So this way also you can leave it. Here I have taken the complete LCM. Here I have taken the LCM of only first two terms, because the denominator was same. So I just added them together. Both are correct. Okay, then I'm ending here. We will be doing the rest of the questions in the next class. Saturday, I want to take a test. So I'll just send you on WhatsApp which topic I'll take. Okay.
Okay, ma'am.
Okay, then you can leave now.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay, Mana. Bye. Thank you.